Okay, so this is starting chapter 12b, and it's using, you're going to see how we use the inverse to solve problems. So if you have a look here, if you're given the scenario of a matrix A plus matrix X equals matrix B, so what's going to happen in these situations, this X1 is going to be the one that you don't know. So matrix X is going to equal the unknown one in these scenarios, okay? Unknown matrix. So what we're saying is that you would have been given A and you would have been given B. So you're told that you've got this matrix A, you add X to it, and it gives you matrix B. So what we're showing you is how you solve for matrix X. So if you think about it, if you get a little bit lost, just think of something like a normal equation. So say, for example, if I had 4 plus X equals 8, wouldn't you solve that? Wouldn't you say X equals 8 minus 4? Is that true? Yeah? And that's how you found what X equals. Can you see that's what we've done here? We said matrix B minus matrix A. Can you see where the X was the unknown? So X was unknown, and we've solved it that way. Okay? Does that make sense? So that's how you would solve it matrix as well. So then let's have a look at this next one. We've got X, and then we say minus A. So we're going to remember that we know this one and we know this one. So wouldn't you, exactly the same, if you think about just numbers, so if I had X minus 2 equals 5, wouldn't you solve it by saying 5 plus 2? Yes, because you move it over the other side. Is that true? So we would normally, we move this over, it does the opposite, yeah? And it's the same with matrices. You can see that's what we're doing. We're saying if I had to find it. So these ones are pretty easy. And now this one, the next one, what we're saying is, so X is still the unknown, but it's getting times by a scalar number. So that means like a 3 or a 2. So, and we're also saying we know this one. So just to make it sort of a bit clear, if I had 3 times X equals 9, wouldn't you solve that by going X equals, because this 3 is times in here, wouldn't it divide on the other side? Is that true? Yeah, so we end up with 9 divided by 3, whatever, X equals 3. So you do the same with matrices. So that one might be just a little bit confusing. So if, for example, I had maybe a half times matrix X equaled, and I'll just make up a matrix and say 1, 3, 4, 6, yeah? See how this 2, if I move the 2 on the other side, yeah, it'll do the opposite. So I'll have X equals 2, and then you just do that matrix like that. That'd be what you'd be doing, yes? So you can just plug it in your calculator, but that one's pretty easier. Scalar is just doing that, yeah? All right, so that was that scenario. Now you're going to see this inverse one. So if you have a look, here's the unknown, and these two we know. So if I just wrote up a little scenario of what would happen there, that's like if I had, so it's the same. If I had 3x equals, 6 or whatever, when you're trying to solve for x, you're going to move this over and it'll divide by 3, okay? So this is where I'm saying you can no longer, if we had the matrix scenario set up and we said x equals, we're going to say matrix B divided by matrix A, we can't do that in matrices. We can't do the divide thing. We're going to do, like I said before, we're going to times by the inverse. So the way you actually solve that is you're going to actually use the inverse and you're going to times it by b. Now, can you see I have put the inverse at the front, haven't I? Yes? So can you see because the unknown, the a is at the front of the x there. So can you see with the difference, and here was what that answer there. Can you see the difference with this second scenario when x is there and the a is after it? Can you see the inverse is used after it? Remember, order is very important in multiplying. So you have to decide what scenario you've got. So often just draw it out like this and see what have I got, where does it go, and that will make a difference. So let's go practice this. So when do we use this? We can use this in simultaneous equations. And you guys did these last year in general maths, but I'm just going to help you. So if you've got the scenario of simultaneous equations, so I might say 2x plus 3y equals 8. I'm just making these up. I don't know. I'm making these up, yep. Okay, if you have that scenario, we can set this up matrix form by doing this. So you put the numbers in front of your letters in the first matrix. So here I'd have 2 and 3, and then I'd had 5 and 1. Can you see I'm making sure the y's are under the y's and the x's? And then I'm going to say times, and I'll put my letters. So the order I've gone there. Ooh, what's going on? Okay, so you can see that the way the letters have gone across there have to be the same order as it goes down there. And then we let it equal whatever our answers were, which was 8 and 12, like that. We've practiced this because if you have a look, remember the run and dive? So you can see we would go run and dive, and that would produce that equation, yeah? So that's how you set matrix up. Now, can you see, if you have a look at it, if I labeled these matrix underneath, say I called that one A, and then I called this matrix X, and then I say this one, I'm going to call this matrix E. Would you say that I've got this one, haven't I? I've got numbers for that one. I've got numbers for this one. This is the one I don't know. So we looked at that before. So the way I would solve that is I want to bring this A on the other side. Now it's timesing, so essentially I want to divide, but we don't divide in matrices, we times by the inverse. So I'm going to use to the power of -1 and times by E. So you can see that we're setting it all up, and here is how that shows you how to do the answer. So because the one was at the front, this is at the front, that's why the inverse is at the front of that. All right, so you can set up equations. If you've got 3 equations of unknowns, so down here, we've got 3. We have put across the top here, we've said X, Y, and Z, and that's why we've gone down that way, X, Y, and Z. So let's go and do some examples. All right. So I can go back, don't worry. Here's an example of 3 equations. So can you see when we set up our matrix here, we've got the X's, we've got the Y's, and we've got the Z's. Now, see in this second equation, there's no Z's, so we've put a 0 there. And the rest we've put on. Be careful, because sometimes if they might not have a Y, they'll just have a Z. So you got it, whenever there's not a letter, you put a 0. And then we wrote it out. So when they ask you to set up in matrix form, the simultaneous equations, this is what you have to write. You have to write this up. This is set up in matrix form, the simultaneous equations. Okay. If they ask you to solve it, this is how we solve it. So this is how you solve it. You will type this first matrix in, and then you raise it to the power of -1, and then you'll times it by that end one. So you're actually timesing in there, and you can see we've done it. So what they've done it in steps. So this is actually the inverse of matrix A. So they found that first, and then they've set it, and then they're timesing it by E. So they've stepped it out, because sometimes they might ask you just for the inverse. They might make you step it out in baby steps. Just be careful. Make sure you're answering what they're asking. All right, so you can do all of that on your calculator. It's mainly they'll ask you to set it up. So I'll show you. I think I put some exam questions here. Good. So if you have a look here, question, this one here. The matrix in the equation below represents a pair of simultaneous equations. These simultaneous linear equations have no unique solution. So, if you have no unique solution, that means you can't solve it. That means the determinant must equal 0. So, if the determinant is going to equal 0, for there to be no unique solution, can you see we've got to work out what the determinant is. So we're going to say, well, the determinant equals 12 times 3 minus 9 times m. 9 times m. So you can simplify that out. That will be 12 times 3, so 36 minus 9m. Now, for there to be no unique solution, we're going to say that equals 0. Okay? And then you can go about solving it. So if I put that, that'd be -36 equals 9m. -36 divided by -9 equals m. So that's +4. Yeah? So for this one, the answer is +4. M can't equal 4 if that's going to have no unique solution. So you've got to just trigger that. When you see no unique solution, right above it, det equals 0, so you'll know. Okay, let's look at the next question. The question 6. A worker can assemble 10 bookcases and 4 desks in 360 minutes, and 8 bookcases and 3 desks in 280 minutes. Each bookcase takes B minutes to assemble, and each desk takes D minutes to assemble. The matrix BD is given by. So if you have a look, what you've actually been given is simultaneous equations. So there's your first equation, 10B plus 4D equals 360. And then your next one is, where is it? 8B, 3D equals 280. So 8B plus 3D equals 280. So if I'm going to go set that up in matrix form, I would put the numbers first. Okay, so we put the numbers first, and then we'd have B and D and equals 360 and 280. That's the setup, but they want you to solve it. So if I was actually solving it, what would be here would be, you'd have this matrix to the power of -1 times this matrix. Okay, so look down there, there's no -1s there, so you might need to work out what the determinant of this one is before you times it. So let's go look at that one. What is that? Okay, so when I pop that inverse in the calculator, and what I actually get is -1.5, 2, 4, and -5. So it will be that times this. So can we see that answer in there? Negative 1.5. Is that there? 2, 4, and that's this answer here. Is that right? Yeah? So there's our answer. We can see that there. So this one is actually the inverse, and then they've actually typed that in first and found out what that is. So lots of kids just find the whole thing in one go. They don't really know what they're actually doing. And I think I just repeated that question. Sorry, it's the same thing. All right, so here I'm just talking about what I talked about before. These are the scenarios when the determinant equals 0. So there we could say no unique solution. This could be what is happening. So we could have the two lines are doing that. The two equations are either parallel and never crossing, or they're actually the same line, or this is the same line. Can you see why that's the same line? If that's 2x, that's x, plus 2y equals 4. Can you see this line, all it is just double, all the numbers have been doubled, so it's essentially the same line. Okay, so what you're going to get is questions like this. So say down here, it says, how many of the following sets of simultaneous equations have a unique solution? So if we are going to have a unique solution, the determinant will equal anything but 0. It can be a negative or it can be, you know what, a positive, doesn't matter. So if you have a look, we've worked out what the first matrix of this simultaneous equation, so you see we've put the 2, -1 and 1, and then they've worked out the determinant by going 2 times 1 minus that. And so this one has a determinant of 1, so yes, it has a unique solution. If you look at this one, the determinant equals 4, so it has a unique solution. This one, its determinant equals 0 in the end, so this one, no unique solution. So if I had to ask how many of these ones have a unique solution, 2 of them, and things like that. There's probably more questions. State whether there is a unique solution for the equation. So all you have to do is set up the first matrix. So if I was doing it manually, there's my thing, and I'd look up the determinant. The determinant of this one would be 2 times -6 minus 4 times 3. So that'd be -12 minus 12. That's -24. So does it have a unique solution? Yes, because the determinant does not equal the thing. With this one, the matrix below, here they're actually asking you, this question here, they're asking you to practice your matrix multiplication. So if we go run and dive, our first equation would have been 2x plus y equals 3. If I do the next one, run and dive, that equation would have been -3y plus z equals 2. And say the last one, run and dive, the equation would have been -x plus 2z equals -6. So one of these equations, you're just looking for one of them. Which one is it? Have we got one of them? This one? Oops. Is that the answer? Yep, there's one of them. So there's the answer, B. Okay. Then down here, another exam question. The four matrix equations below each represent a set of simultaneous equations. The number of these that have a unique solution. So unique solution, we're looking for the det to not equal 0. So if I look at this one's det, it would be 2 times -1 minus 1 times -2. So we get -2 plus 2. So that one will equal 0. So this one does not have a unique solution. If I'm looking at this one, its determinant would be 3 times 4 minus 6 times 2. So that would be 12 minus 12. That would equal 0. That one doesn't have a unique solution. This one would be 6 times 1 minus 3 times 2. That's 6 minus 6, so that's 0. It doesn't. And the very last one would be 1 times 1 minus, is that 0, 2? So how many have a unique solution? None of them have a unique solution because they all equal 0. Okay? Okay, last little page. Nearly there, boys. So here's just to show you what the exam will look like and even your SAC. So the basketball coach has written 3 linear equations which can be predicted the number of points, rebounds and assists that Oscar will have in his next game. So there's the equation. These equations can be written in matrix form. So all you've got to do here, because they've done points, rebounds and A, so we're going to have points, rebounds and A, you just put the numbers that are in front of those equations. So we've got a 2, -1 and 3, and the last one is a 1, 2 and 1. Okay? The matrix equation can be solved the following way. Determine x. So when you're trying to find x here, which is there, but we know this is the inverse. So what this matrix actually is that first one, 1, 1, 1, 2, -1, 3, and 1, 2, 1, raised to the power of -1. So we'll do that on our calculator. Okay, so I've done that on my calculator, and I know I've done it right because I've got all the numbers that are similar to what they've got. And then in the x spot is the -5. So what is x? Is -5. How many rebounds is Oscar predicted to have in the next game? So you are actually going to calculate this and you'll get an answer. So if we calculate it and I do this matrix times that matrix. Okay, so we calculate those two matrices times together and you end up with 19, 10 and 4. So be careful though, what the question asks is how many rebounds will Oscar, so you just want the rebound part, so you need to just write that out. So how many rebounds? 10 rebounds is what you need to write, okay? And that's it, so you can now do 12A and 12B.